Hello students, today's in this session we are going to start exercise 13.1 chapter number 13 surface area and volume, which is based on the surface areas of cube and cuboid. So let's start the problems. Question number 1 says a plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. It is opened at the top. Ignoring the thickness of the plastic sheet, determine area of the sheet required for making the box as well as the cost of sheet for making the box. If a sheet measuring 1 meter square cost is rupees 20. Now remember, we have given the three dimensions, that is the figure made will be the which? Yes, cuboid. So here this is the figure where it has the three dimensions. This is the length, this is the height and this is the breadth. Now remember one thing here, the box is opened at the top. So for making the box we need not to join the upper face. Top face we will not include. This point we should remember that the top face we will not include for making the box. Now we have to make the box, that means we need the total surface area, but the top will not include. So from the total surface area we can subtract the top rectangular area. In this way also we can find the area of the sheet. So let's start the solution. As we have given, the length is 1.5 meter, breadth is 1.25 meter and height is given 65 centimeter. So it should be converted in the meter, as all the dimensions are given will be in the same unit. So this 65 centimeter we convert this in the meter as 0.65 meter. Now it is open from the top, so we have the surface area of the box will be all surrounding four faces, that is lateral surface area plus area of this base. In this way also we can calculate, and earlier what I said, the total surface area we can find out and the upper top area we can subtract, or in this way we find out the lateral surface area, that is surrounding all four faces area, plus area of base will be the sheet required for making the box. So formula for lateral surface area, we know that twice of L plus B into H. As in the earlier classes we have done with this, how to calculate the lateral surface area, that is front and top, side, left and side, four faces. That these four faces will be the lateral surface area, and the left and right side faces gives the height and breadth. So that means 2 times of L, 2 times of H and B. Similarly back and front faces gives the height and length, so H into L. So when we take 2 and H as common, so we get the lateral surface area formula twice of L plus B into H. Remember, with the formula of lateral surface area is twice of L plus B into H. Base area, now let's take the base. Base is a rectangle where this is 1.5 meter is the length and this is the breadth. So 1.25 meter is breadth. So area of the base is the area of rectangle, L into B. Now put the values. Twice of L is 1.50, B is 1.25 and H is 0.65 meter square. And for area of base we have 1.50 is the length and 1.25 meter is the breadth. So by calculating all these and when we simplify all these terms, we get the surface area for making the box is 5.45 meter square. So here we get the area of the sheet required for making the box is 5.45 meters square. Now second point, we have to find out the cost of sheet which required to make the box. So what will be the cost for this much sheet? So given here 1 meter square cost is rupees 20. So this 20 multiplied by the required area of the sheet. So 20 into 5.45 gives 109. So we can say the cost of the required sheet is rupees 109. Let's take the third question. The floor of a rectangular hall has a perimeter. Now floor of a rectangular hall, that means a cuboid is there, and perimeter of the floor, that means perimeter of the rectangle is also given 250 meter. Now perimeter is twice of L plus 2 into L plus B is the perimeter of the rectangle. If the cost of painting the four walls at the rate of rupees 10 per meter square is rupees 15,000, find the height of the hall. So here a rectangular hall meaning a cuboid, and the length and breadth of the hall we can write it as L for length and B for breadth. So perimeter is given. Perimeter of the rectangle is 2 into L plus B. Now 2 into L plus B, that is given 250 meter. This is the perimeter of the base given 250 meter. So we can say 250 meter is equals to twice of L plus B. Now we have to find the cost of painting the four walls. Now four walls, that means left and right side faces, front and back. That these four walls are the lateral surface area. So we have to find here the lateral surface area. Now the area of four walls, that is the lateral surface area. So we can say the formula for lateral surface area is twice of L plus B multiplied by H, where H is defined as height of the hall. So cost of painting the four walls, that is equals to 100 into 250 H. 10 into 250. Now this 10 is given rupees, and 2 into L plus B, it is given 250. So 250 into cost 10 multiplied by H, it is 2500 into H. Now when we multiply it, we get 2500 H. Now it is given total cost of the painting is 15,000 rupees. So that meaning 2500 H, it is equals to 15,000. These two costs are same. So we get the value of H is 6. From this equation, 15,000 divided by 2500 becomes 6. So we can say the required height of the hall is 6 meter. Now let's take one more interesting problem. The paint in a certain container is sufficient to paint an area equal to 9.375 meters square. Now whatever the paint is in the container, by that paint we can paint the area that measures 9.375 meters. This much area we are able to paint from the paint inside the container. How many bricks? We have to find it out. How many bricks, how many number of bricks we can paint by this container. Remember here the question is saying whatever the quantity of the paint in the container, we are able to paint how much area? 9.375 meters square total area we can able to paint. But if the same container of the paint we apply for the bricks, and the dimensions of the bricks is given, so how many bricks we can paint it out from the paint of the container. So here what are the given quantities? how much area we are able to paint, that is 9.375 meters square, and the dimensions of the brick is given also here. L is 22.5 centimeter, height is 7.5 meter, and breadth is 10 centimeter. Now, as we know that brick is a shape of cuboid, so the total surface, as we have to paint the brick, that meaning all the 6 faces we have to paint, correct? So all the 6 faces when we have to paint, that meaning we have to find it out the total surface area. All the 6 faces we will paint, that means the total surface area or total brick we are able to paint. So the total surface area of the brick, that is the total surface area of cuboid, and the formula is twice of LB plus BH plus HL. Now put the values of length, breadth and height. We get twice of 22.5 into 10 plus 10 into 7.5 plus 7.5 into 22.5 centimeters square. Now further, when we solve it, we get the required area of the brick. That means we are finding here the area of one brick is 937.5 centimeters square. Okay. Now what we have to ask here, how many brick we can paint for this. Now here, as the problem says, how much area, total area can be painted by the paint, it is in the unit meter square, whereas we are calculating the area of one brick is in terms of centimeter. So here first of all we have to convert this area of a brick from centimeter square to the meter square. So as we know that 100 centimeter is equals to 1 meter, or we can say 1 centimeter is 1 upon 100 meter. So when it squared in both the sides, we get 1 centimeter square is 1 upon 100 meter whole square, or 1 centimeter square is 1 upon 10,000 meters square. So 1 centimeter is 1 upon 10,000 meters square. So for the required area of a brick, 937.5 centimeters square will be converted into the meter as 937.5 upon 10,000 meters square. Now the areas of both brick as well as the area of what we can paint, it is same in units meter. Now let's solve the next. The required number of brick we are asking here. So let the required number of brick is defined by Y. So total surface area of Y brick. Now here remember 937.5 centimeter square, this is the area of this only one brick, and it is into the meter square is 937.5 upon 10,000 meters square. Now this is the area of one brick. How many bricks we are taking? Y. So total surface area of Y number of bricks will be Y into 937.5 upon 10,000 meters square. Now remember one thing. It is given that the paint is sufficient to paint the total area. How much can be painted by the container is 9.375 meters square. And how many number of bricks can be here for total surface area? Y into 937.5 upon 10,000 meters square. So we have both the areas are same. This is also the area which can be painted by the same container, and this is also the area which can be painted by the same container. So these two areas are same, so we can arrange equate them as 9.375 meters square is equals to y into 937.5 upon 10,000 meters square. Now when we further simplify it, we get this 10,000 multiplied by 9.375 and it is equals to 937.5 y. So when we divide this decimal, first we remove this. So when we remove this decimal, we get 9,375 upon 1000 into 10,000. Now these 3 zeros will be cancelled out from these 3 zeros. So in the next step, we get 9,375 into 10 is equals to 937.5 y. Now for y, we get equation as 9,375 into 10 upon 937.5. Here again, when we remove this decimal from the denominator, we get in the numerator multiplied by 10. So now the step which we are getting here, 9,375 into 10 upon 9,375. Now these two 9,375 from the numerator and denominator, they will cancel out. So we get 10 into 10, that is 100. So here we can say 100 bricks can be painted by the paint of the container, which is able to paint the area 9.375 meters square. So here number of bricks 100 which can be painted by the paint of container.